An electron is released from a metal surface with that speed. When a wavelength of that is shone on it, what is the work function? Okay, so that's okay. We can use our formula. Our formula is minus work function plus HF equals kinetic energy. So here, work function equals kinetic energy minus HF, which is a half mv squared minus HF, which is a half mv squared minus hc over lambda. No?
From the first line to the second line.
It's very wrong. Thank you. HF minus KE.
Yeah.
Yes, thank you. HC over lambda minus a half mv squared. What's the lambda? It's 600. And what's the V? 154471 squared.
Why is the frequency C over lambda? That's for, but does the electron travel at the speed of light?
No, this is for the photon.
Oh, yeah.
Yes. Right. .2 times 10 to the minus 19 joules. Did you get that, Grace?
No.
What did you get?
1.5.
Where's the problem?
Formula.
Which formula?
Everything's up.
Okay. A photosystem of a plant is made up of magnesium with a work function of 3.68 electron volts. A photon of UV light from the sun hits the metal surface. How much kinetic energy does the freed electron have? So what happens here is you have your plant. Look at that. Beautiful. I'll make it blue. Right, now, the way these things work is your plant actually has on it, it has magnesium. So what happens is the UV light, or other light, from the sun, it hits the magnesium, and the magnesium then frees an electron. And this electron has energy. And this is what the plant uses for energy from the sun. So the sunlight hits the magnesium frees an electron. What energy does the electron have? Kinetic energy. And this is what the plant uses for energy.
That's the food.
Yeah, you heard from photosynthesis, getting energy from the sunlight. That's how it works.
So it's eating electrons basically.
Well, it's eating photons, and it's then it's putting the energy in an electron in kinetic energy. This is how the energy is taken from the photon as kinetic energy of an electron. Now, what it does with the electron after that, ask a biology student. I just know this much. Okay, so it uses the electron to grow and repair and all of that, but that I don't care about. I only care about this part. So the question is, how much kinetic energy does this electron have? So again, we have our formula, minus work function plus HF equals KE. The work function is 3.68. but we have to multiply it by E to make it joules. And the frequency we don't know, but we know the wavelength is 300. So this would be hc over lambda. Yep. F equals c over lambda, because c equals f lambda is a formula. You might remember it like this, Grace. V equals f lambda. Yeah. Right, so let's calculate the kinetic energy here. Kinetic energy is 7.25 times 10 to the minus 20 joules. Or if you're wondering, that's 0.45 electron volts. It's okay, Sogi? You don't look happy.
My throat is
Ah, okay. Did you have some fish last night? Okay, good. Okay? Yes? What's the next part now? What is the threshold frequency? So if you remember the formula here, threshold frequency is work function over h divided by h. Yep. I got 8.898, but whatever. Times 10 to the 14 hertz. Okay. Next is what is the wavelength. So then the wavelength will equal c over f. (3.369 times 10 to the minus 7 meters). Or if you want, that's 337 nanometers. Minus 9. Yeah. Okay. Yeah. Trust me, I use my calculator. What type of light is this? I think this one here is UV light as well. But it might nearly be purple color. You see, because when you think about the rainbow, it goes red, orange, yellow, green, blue, indigo and violet. These look like purple. And then after that is UV. So it's kind of around about here on the diagram. So it's maybe it's purpley, maybe it's UV, it's down that end. Okay. A 10 by 10 photocell is made of copper with work function 5 electron volts. Okay. So what we have here is 10 centimeters, 10 centimeters. We have our light coming in. This is copper. Its work function is 5 electron volts. The light has wavelength of 650 nanometers. And the intensity is 120 watts per meter squared.
Underneath the wave function, you have to change it to joules.
Everything should be in joules, yeah. Okay? Yep.
How is this 100?
Oh, it's given. Yeah. So, how much light energy does this get per second? The answer is it's 120 joules per second, because I told you in the question it's 120 watts per meter squared. So that means per second it gets 120 joules. Now they want to know how many photons that is, or I want to know. So energy equals NHF. Why have I got the N here? There's many photons. So the N is E over... Oh, abort! Stop! Crash! Funk. It's not, well, it's 120 joules per meter squared. Do I have a meter? No, I only have a small amount of it. How much do I have? If this is 10 by 10 compared to 1 meter squared, that's 100 and 100. So how much do I have? Is it a tenth? Well, the total area would be 100 centimeters squared, and the area I have is 10 squared. So if you put that down, let me just write it down here. Cancel. 100. This here is for a meter squared, but in the question I don't have a meter, I only have this much. So it's not 120, it's 1.2 joules per second. Okay, now I can go to what I was doing. E equals NHF. So N equals E over HF, which equals E over HC over lambda, which equals... Okay, so the E is 1.2. The H is on my calculator. The C is also on my calculator. And the lambda is 650 nano.
The E is
1.2 joules.
What is it on the calculator?
Which E?
Did you say the E for the calculator?
No, I said the H and the C. Yeah. So that's 1.47 times 10 to the 26. That's the energy it gets from the light, which I have this one here.
It's 1.2, right? The E, the big.
Yeah. 1.2 joules a second. Yeah.
But can the answer be 1.47? Does it have to be a whole number? Or can you answer it in decimal?
Oh, this is fine. This is a whole number. Because you have 26 zeros. Yeah. Okay. Then the last part, how many electrons are freed per second from the surface? So, what was the work function? 5 electron volts. Yep. So this question here is a little bit sneaky. This is how many photons you have. If each photon hits an electron, what should happen? It should free it. Yeah, it should ionize it. If it has enough energy. How much energy does it need to free an electron? It needs 5 electron volts for each photon. So let's just change that into joules. That's 8.01 times 10 to the minus 19 joules. So the threshold frequency the minimum frequency required to free the electron. Yeah, sorry, thank you. 8.27 times 10 to the minus 16. That's the threshold frequency, and the frequency we have. What did I say the wavelength was in the question? 650, was it?
Yeah.
So, look what happens here. The frequency of our light is this. I think I typed in something wrong here. Let me just double check that, sorry. Yeah, sorry, I typed this in wrong, sorry, that's 26. No, I typed that in wrong again! Is it 5 electron volts for the... Yep. Sorry, I was right the first time, minus 16. Okay, so, is the frequency of our light big enough?
Why is it, is it positive 14 or negative 14?
Yeah, it's positive. I'll double check, it seems strange, doesn't it?
Why is the frequency so big?
Yeah, seems odd, doesn't it? But that's the frequency for red light, I think it is that big. I'll double check it for you since you seem worried, and so am I. Maybe I made a mistake. Nano is minus 9, isn't it? Yeah, no, it is positive 14. Right, so this is the light we have, and this is the frequency we need. So is our frequency big enough to free the electron?
Yeah.
Oh yeah. It's so big that the electrons will have lots of kinetic energy after they're freed, because it's much more than what we need. So my point is, each of these photons has enough energy to free an electron. So each one should free an electron. So the answer is also this for the last part. So C, it is also 1.47 times 10 to the 26. Each one has enough energy to free it.
What's the answer for this? I mean, like, what are we supposed to find?
How many electrons are freed per second?
And
Harian, the answer could have been 0, because
I get it, yeah.
if the frequency wasn't high enough, then none of them would be freed. Did you get the part before I said 0?
No.
Oh, okay.
After the need is much bigger than the
Yeah, so this is the frequency of our light, and the F0 is the threshold frequency, how much we need to free the electron. We have more than what we need, so the electron is freed. So each photon will free an electron, so the answer is the same as the last part.
So for the up one, that is how many
Photons
so at the bottom is how many electrons
are freed. So yeah, in other words, each photon will free one electron.
So it's always the same, like each photon one electron.
Yeah. The freed electron will have kinetic energy. We don't need to work it out. Will it have a lot or a little kinetic energy?
A lot.
It'll have a lot. Why, Harry?
Because the wavelength is much higher.
The frequency.
Yeah, the frequency is much higher than the threshold frequency.
Yeah, so it has extra energy to put into the kinetic energy. Is that okay?